So, okay, so maybe I'll start off with talking about what data science is, all right? I understand that some of you may have heard about what it is tons of times, okay? So what I'll do is I'll just explain enough because this is where I'm going to anchor the discussion, all right? So what has happened in the past few years is that data science, there's a lot of different flavors of data scientists that have appeared the past few years, right? I've encountered data scientists who build who productionalize predictive models. I've encountered data scientists who focus on the spatial aspect of things, mapping, that sort of thing, cartography. I've also met a couple of data scientists who focus on policy work, right? So just there's a pretty broad spectrum of what data scientists do. But what seems to tie all of these flavors together is that it's a multidisciplinary approach in problem solving, right? So some of you may have already seen this diagram behind me. Basically, there are four areas that are used in data science. The most common three that are cited are, of course, statistics, programming, and business/domain. And one of the underrated areas is communication. All right. So for those of you who have encountered this Venn diagram for the first time, basically the story is statistics is used to understand what to do with the data, how to get a specific insight from them using your different models and such. And programming is used to handle the data because the data sets are housed in IT tools, right? And business is to understand what problem there is and what's needed to solve it, all right? So all of these are tied together by knowing how to handle the data, what to do with it, and what problem to solve. Now, the usually missing, how would I call this, facet of data science that is not as explained much is communications. Because data scientists tend to be very technical people, right? They talk about p-values, r-squared, gradient descents, etc. But typically the beneficiaries of the data science projects don't understand those terms. They use terms like profit margin, ROI. You may think that I'm a sellout. I'm a sellout, but I also understand impact, right? Wellness. It's a bit obvious that my vocabulary for welfare is a bit low. But no, the point is the people who get value or who are helped by data science are not technical people. And that's where communication comes in, all right? And I'll tell you a story. One of the reasons why communication is very important, because typically, a data scientist can talk to programmers, can talk to other analysts, and can talk to the stakeholders. A data scientist would typically shift languages, right? What do I mean by that? There was a time when I was approached by an economist wanting to explore the use of technology in her work. And she wanted to explore web scraping to get data from a famous traveler website, right? And get some, and relate it to GDP, right? Now, of course, that economist would have limited knowledge on HTML. And so she asked, oh, what is this web scraping? How can I use it? How do I get economic measures from this website? And so, I turned to a friend who has a background in computer science and a bit more versed in the IT side of things, right? So I basically performed the role of a matchmaker, but I did not leave them to their date alone. I had to be the chaperone. Because, for example, the economist asked, all right, how do I get I need to get, say, the sentiment of the people about locations in this country. The IT person would understand that differently. All right, so I had to translate, okay, there needs to be some scraping involved, the API of this website has to be accessed, right? So that sort of thing, there's a translation that happens in between. And that's where data science comes in, understanding the needs in between flows from one side to another, right? And part of this communication is, of course, a wide vocabulary, okay? I'll give you another example. When you typically say you want to analyze the transactional behavior of customers, all right? So what you typically do is you get the transactions per customer and you sum them, average them, or whatever. If you're talking to a statistician, it's called summarizing, right? Descriptive statistics. If you're talking to a programmer, it's called aggregation. And if you're talking to an accountant, it's called grossing up, all right? And a summary may be different in meaning to a programmer. So that sort of thing, all right? So definitely, you will always see the three areas, the quant side of things, the programming side of things, and the business or domain side of things. But don't forget that communication is also important in data science, all right? So that's where we'll anchor our discussion, those four areas. Next slide, please. All right. That being said, I've already touched on this. Data science always sits in between the data and action. Okay, cool, Carl, obvious insight. Here's my point. Without data, data science is useless. Without people to inspire an action for, data science is useless. All right? So by nature, data science is a team player. Okay? So, just as an FYI, the three diagrams on the right, these are the typical data sources. You know, spreadsheets in your local machines, databases, and the web. And typically, the kinds of actions that you derive from these data are typically just about in two types. You have problem solving, the one that's above, the small icon to the left above. Although what's funny is if you look at the icon, it's not problem solving. Can you guess why it's not problem solving? Yes, it doesn't fit. That person will never fit that puzzle piece on the set. So anyway, but it's a set icon from Google, so I didn't do that, huh? All right. So the uses of data science is to look for solutions to problems from the data set, or sometimes they advance improvement, or they try to improve. So the difference is, one is it's a problem first, solution after. The one at the bottom is the solution first, value after. And those are the two approaches of solving data science, problems using data science. All right? So, one of the most common approaches I've seen that companies take when solving problems using data science is they take the top-down approach, right? They have a problem, they want to look into the data, and using data science, find a solution to the problem. Why are our customers leaving us? Why are we not getting enough reach? Those sorts of things. Okay, dive into the data, swim, and find an insight. Oh, this is the insight that we're looking for. And then inspire action. Now, it's not always the approach in solving data. There is another way, and this is the typical approach that I see from data scientists. It's the bottom-up approach. They start with a data set, then they learn a new model. This is an interesting model. This is an interesting data. They put one and one together. Look at this new thing that I can do. And then they look for ways that it can help the organization or what problems it can solve. All right? So the bottom-up approach is typically what data scientists live for. It's fun using new models. But the problem with it is it doesn't always guarantee results. Okay, and later on, I'll give you an idea of one example of this, how would I call it? Pitfall. Okay? The top-down approach, in the meantime, is what organizations like the most, because they can feel what the output is going to look like and can understand the value from the very get-go. But of course, the issue with the top-down approach is the timeline is not always guaranteed because there might be some roadblocks in between. Okay? So really what I'm saying is data science isn't always used for problem solving. It can be used to innovate and look for value by expanding the kinds of questions that what decision makers can realize, right? I want to make it clear, it's top down and bottom up. Walang S. Okay? It's not bottoms up approach. No. Iba yun, hindi data scientist yun. Okay? So for this talk, I'm gonna focus on the top-down approach. Okay? My illustration will be what happens behind the scenes in problem solving in a data scientist's mind. Alright? Alright. So what I'm going to do is, well, I've talked about data scientists as individuals,